Welcome to Pre-Calculus Trig. This is section 1.3 on trig functions of any angle. So we'll start with what we know. We know how to find the 6 trig functions of acute angles in a right triangle, and that's what we did in the prior section. Now we want to find the 6 trig functions of any angle where theta lies between negative infinity and positive infinity. We know that this setup here, where theta can be anywhere in this domain, is possible if we put our angle on the coordinate system. And we defined how that worked in the last section. All right, to find our 6 trig functions for any angle in this domain, we need to define what we call the reference angle on the coordinate plane. Reference angles are positive acute angles. So if we're working in degrees, the reference angle will fall between 0 and 90 degrees. If we're working in radians, the reference angle will fall between 0 and pi/2 radians. Let's briefly review angles in standard position. So this is your x and y plane, your xy plane. This is a positive rotation. This is a negative rotation. So if you're talking about an angle in standard position, you have the initial side, which lies on the positive x-axis, and the terminal side, which could lie in either quadrant. Okay? Let's just look at one of these angles here. Let's take, for instance, this angle in the second quadrant. So an angle with the same initial and terminal sides that has a different amount of rotation. So let's illustrate that. So this could define this angle here. Also, we could rotate in the other direction and we could have this angle here. They have the same initial and terminal sides, but different measures. Of course, one is a positive angle and one is a negative angle, and they have different measures. So these are called coterminal angles. Now we can have infinitely many angles that have the same initial and terminal sides by simply adding or subtracting full revolutions. So I can go around any number of full revolutions and end up on that same terminal side. So in either direction, so I can add another revolution. So you could keep going around and around and around in the positive or the negative direction, adding full revolutions, and wind up on this same ray, this same terminal side. So that shows us how we can have angles that lie within the domain negative infinity to positive infinity. Now let's talk about reference angles. So if I have an angle in the first quadrant with the initial side here and the terminal side lying anywhere in the first quadrant, in order to get my reference angle, I drop a perpendicular down to the x-axis, always to the x-axis. Now I've created a triangle where this is my reference angle here between the ray and the positive x-axis here. All right, so now I can define my 6 trig functions based on that angle theta using our knowledge about how to do that in a right triangle. So I can do that in any of the quadrants. Let's take a look at each quadrant. So if I had an angle in the second quadrant, its terminal side would lie here. So once again, in order to determine the reference angle, I drop a perpendicular to the x-axis to create a right triangle. And then I call this here my reference angle, which is the angle between the x-axis and the ray. So this is a positive acute angle. So if my terminal side was in the third quadrant, then I'd also drop a perpendicular to the x-axis, it's always to the x-axis, to create a right triangle, and my reference angle is defined as the angle between the x-axis and the terminal side. So I've got my triangle. You can see theta is an acute angle. It's a positive acute angle. That's my reference angle. So then you could have a terminal side lying in the fourth quadrant. So I would drop a perpendicular to the x-axis to create a right triangle. And my reference angle is defined as the angle between the terminal side and the x-axis. So I've got my right triangle again. The angle theta there is an acute angle, and it's a positive acute angle. So these thetas that I just showed you are what we call the reference angles for any terminal side, regardless of what quadrant you're in. Now let's talk about how we get the 6 trig functions from these reference angles. So let's take a look at the first quadrant where we have our initial side and our terminal side and our reference angle that we achieved by dropping the perpendicular down, and this would be our reference angle here. So the first thing that we do is we define a hypotenuse as being r, and that's going to be the length of that ray here. So this is considered your r. Okay, and what the parallel is to that is, think of that as being the spinner again, where I could go around in a full circle like this, and that r is like a radius of that circle. So we call the hypotenuse r. Then we look at a point xy on that imaginary circle of radius r. So it's at the tip of the radius r, which is the hypotenuse. And we say that this dimension x would be the dimension that goes from the origin, this horizontal distance here, representing the x coordinate in this coordinate pair. So that's the distance x, and then this would be the distance y, all right, which is the typical way we define x and y coordinate pairs. So if I'm standing on the angle theta, that's my reference point, then y is my opposite side, x is my adjacent side, and of course r is my hypotenuse. So I can use my knowledge of SOHCAHTOA to fill in my table here. So sine is opposite over hypotenuse, so that's y over r. Cosine is adjacent over hypotenuse, so that's x over r. Tangent is opposite over adjacent, so that's y over x. And then I find the reciprocals to fill in the other side of my chart. Reciprocal, I just turn the fraction upside down. So I've defined my 6 trig functions for an angle theta that lies in the first quadrant. Now, let's take a look at the second quadrant. So I drop a perpendicular to form my reference angle. So here's my angle theta here. So I look at a point xy at the end of the ray, which is my terminal side. So this is my r, same reason that we described for the first quadrant. So the hypotenuse is always going to be positive. Make a note of that. The hypotenuse is always positive. All right, and then I've got my x and my y. All right, so if I'm in the second quadrant, my x is going to be negative, my y would still be positive. So if I fill in my chart standing on my reference angle theta, this is opposite This is adjacent. This is hypotenuse. So sine is going to be y over r. Cosine is going to be negative x over r. And tangent is going to be y over negative x. Well, I just put my negative out in front. Right? So then I flip these over to get the other side of my chart. And then I'm done. I've defined my 6 trig functions for an angle that has a terminal side in the second quadrant. So then if I had the terminal side in the third quadrant, and I created my reference angle by dropping the perpendicular to the x-axis, here would be my reference angle. So I've got this point xy at the tip of the ray defining the terminal side, and this is my radius r, which is my hypotenuse, which is always positive. This is my x, which would again be negative, and this is my y, which would be negative in the third quadrant. So we've got 2 negatives in the third quadrant. All right, so if I'm standing on my reference angle, I've got opposite, adjacent, and hypotenuse once again. So I could fill in my chart. The sine would be negative y over r. The cosine would be negative x over r. And the tangent would be negative y over negative x, which is going to turn that into a positive tangent. Right, so the cosecant is going to be the reciprocal of the sine. The secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. So we can just erase these here. Okay, so we've just defined our 6 trig functions for any angle that has a terminal side that lies in the third quadrant. And the fourth quadrant, the terminal side would lie somewhere in the fourth quadrant. To create the reference triangle, we drop the perpendicular to the x-axis and define theta between the x-axis and the terminal side. So then we've got r again, always positive. Here's our point xy at the end of the ray on the terminal side. So then we've got a positive x this time and a negative y in the fourth quadrant. So standing on my angle, that means this is opposite, this is adjacent, this is hypotenuse always being positive. So I can fill in my chart. The sine is negative y over r. The cosine is x over r. The tangent is negative y over x. And then the reciprocal functions, negative r over y, r over x, and negative x over y. So we've defined our 6 trig functions for an angle that has a terminal side which lies in the fourth quadrant. So the last thing I want to say about this is that any of these terminal sides defines infinitely many measures, but only one reference angle. So to summarize what we just talked about with the reference angles, your sine, cosine, and tangent, and then their reciprocal functions, are going to have either positive or negative signs on them, depending on which quadrant you're in. So if you're in the first quadrant, where your x and y are all positive values, then all of your trig functions, sine, cosine, tangent, and the reciprocal functions are all going to have positive values. Now if you're in the second quadrant, where your x is negative and your y is positive, you're going to have some negative values on some of the trig functions. So the sine function will be positive, the cosine function will be negative, and the tan function, which is made up of sine and cosine, if you think about that. So tangent is the quotient of the sine and the cosine. You're going to have 2 signs that make up your tangent. So if one of them is positive and one of them is negative, then you're going to end up with a negative quotient. So your tangent is going to be negative in the second quadrant. So in the third quadrant, you've got a negative x and a negative y. So that means you're going to be negative sine, negative cosine, but your tangent's going to have negative divided by negative, so your tangent is going to be positive. Right in the fourth quadrant, your x is positive and your y is negative, so your cosine, which is your x over r, this is going to be positive, your sine is going to be negative, and your tangent is going to be negative divided by positive, which is going to be negative. So the sine and the cosine doesn't usually cause too much confusion. But when you talk about the tangent, your tangent is positive in the first and third quadrants because the signs of the sine and the cosine are the same, either two positives or two negatives. And the tangent is negative in the second and fourth quadrants because you have one positive sign and one negative sign in the quotient. So sometimes the tangent can cause a little bit of confusion because the sine of the tangent is based on two functions, the sine and the cosine functions, which have their own signs. So we've got to be careful there. So this slide here is just a summary of everything we've talked about up until this point. So make sure you've got all of this written down in your notes. So this will be the end of part 1 of our lecture for 1.3. The next part 2 of our lecture, we'll do some example problems.